Hello. In today's video, we're going to be looking at the properties of matter. In this video, you should be able to compare the difference between a chemical and a physical change, illustrate the difference between extensive and intensive properties, and summarize. Hey guys, in this video, we're going to be talking about the properties of matter. In this video, Hey guys, in this video we're going to be talking about the properties of matter. By the end of this video you should be able to compare the differences between a chemical and physical change, illustrate the difference between extensive and intensive properties, and summarize the differences between kinetic and potential energy. So think about matter, our physical substance of our universe. Each different substance is going to have unique properties. So each substance has unique properties. Okay, so a property is a characteristic of a substance. And it is going to allow you to differentiate or distinguish it from other substances. Okay, so we look at properties as either chemical or physical, or intrinsic or extrinsic. So physical or chemical, intrinsic or extrinsic. So let's first look at our physical and chemical properties. So with our physical properties, these are going to be observable properties. So properties we can look at the. So our physical properties are going to be ones that we can observe without changing the chemical identity of the substance. Some examples are going to include color, odor, density, the melting point, and the boiling point. Okay, and then our chemical properties are going to be ones that are observable only during a chemical change. So we have to cause a chemical change to occur in order to see these properties. So a chemical change is the same as a chemical reaction. Okay, so some examples of this are going to include flammability or reactivity. To look at our intrinsic and extrinsic properties. So if we're talking about our intrinsic, or also call it intensive properties, these are going to be properties that are going to be inherent. So they are dependent on the material itself. And only the material. So the amount does not matter. Some examples include density, boiling point and melting point, and temperature. Okay? Also called extent, are going to be properties that depend on the amount of substance. So these are going to be things that are going to change based on how much of it you have. So our examples here are going to include mass, volume, and length. Okay. We can then look at, now that we know our properties, we can look at our changes. So we have physical changes and chemical changes. So let's start with a physical change. And one of the most important physical changes we're going to look at, so I'm going to include it in here, are changes of state. So our physical change is going to be a change in the appearance of the substance, but we're not changing our chemical identity. So no change in chemical identity occurs. Just a change in the appearance. Okay. So one that is often mistaken for a chemical change is a change in state. That is a physical change because we're not changing our substance. So our change of state are going to be physical changes. So this is going to include going from a solid to a liquid, which is called melting, or going from a liquid to a gas, which is evaporation, or going from a gas back to a liquid, condensation, or from a liquid to a solid, freezing, or lastly going from our solid to our gas, sublimation, or our gas to our solid, deposition. So each one of these, we still have the same substance, so we're not changing our chemical identity, so this is still considered a physical change. Next we have our chemical change, which is the same as a chemical reaction. So here we're actually changing our chemical identity. So the chemical identity is changed. You do not have the same substance that you started out with. So we call this a rearrangement of the atoms. And during this rearrangement of the atoms, we form new compounds or molecules. An example of this might be the burning of methane, or any combustion reaction. So in the burning of methane, we react methane with oxygen to produce water and carbon dioxide. And hopefully you can see from this that we are rearranging our atoms, so this is a chemical reaction. Another example is the rust iron. Another example is the rusting of iron. So we take our iron solid, react it with oxygen gas to produce iron oxide, the chemical formula for rust. Okay. Okay, the last thing I want to talk about in this video is the idea of energy. Energy is going to be the capacity to do work or transfer heat. So when we have energy, either work energy or heat energy, and then energy can either be potential, which is stored energy, or kinetic, which is movement energy in nature. Generally, when we're talking about energy in chemistry, we're talking about heat energy. Not a lot of work occurs in chemical reactions. So we don't look at it too much, but let's go ahead and just define it. So work is a measure of energy transfer that occurs when an object is moved over a distance by an external force. So this is going to be work is equal to force times by distance. The further that you move something, the more force that's exerted during that movement, the greater the work is going to be. And heat is going to be a form of energy that is associated with the movement of atoms and molecules in any material. So all of our matter. Generally, we think the higher the temperature of the material, the faster the atoms are moving, the greater the amount of energy present as heat. And then we think about heat flow from a warmer substance to a cooler one or a colder one, so that's where the heat flows itself. When we think about temperature, this is going to be a measure of the average kinetic energy of the system. Okay? And it's a property that basically tells us the direction of heat flow. Where heat will flow from a hotter object to a cooler one. And then the rate of heat flow depends on the temperature differential. basically the difference in temperature. The greater the temperature difference, the greater the heat flow. And then let's just finish up looking at our potential versus kinetic energy. Okay, so again, our potential energy, so I'm just going to do PE, potential energy, is our stored energy. And one of the most common potential energy sources we look at is electrostatic potential energy. So our electrostatic potential energy is an interaction that is interaction between charged particles. And we will bring up electrostatic potential energy many times. And we also have chemical potential energy, basically the energy stored in the arrangement of atoms within a molecule. When we think about eating food, that's kind of taking that chemical potential energy and converting that into kinetic energy. And lastly, our kinetic energy, or KE, our movement energy, or energy of motion. That's going to have the following equation. Kinetic energy is equal to 1/2 mass times velocity squared. So depends on the mass, depends on the velocity. And that's it for the properties of matter. I will talk to you guys later.